Hello everyone, nice to be with you about this webinar about how to acquire hyperspectral data from UAV. I am Mathieu and I'm really happy to be with you here with this webinar, and you will see I'm not alone. We have a guest star with us which is coming later to speak about it. But first, about who I am. So, you know me, I am Mathieu Marmion, working at Speaking for 13 years. And I'm working nowadays as a lead application specialist. And as said, I'm really thrilled to be here with you for this webinar. And as said, I'm not alone. Then, about the agenda. First, I will give a short introduction about the company, who we are. After that, I will highlight some presentations, some applications, about what we can do with the hyperspectral data from airborne. Then I will highlight as well our AFX series, the products that we can supply for this type of application or environment. Then we're going to have our guest, Petri from SMAPS, who is going to introduce himself and also to give more comprehensive information about how to choose your UAV, where you can put the camera. Also how to simply attach it without gimbal, fixed mount, these kind of things. And also, you have to keep in mind that when you want to fly with a hyperspectral camera, in order to be efficient and to get high quality data, you need to plan carefully how to fly. So here we're going to have actually a full chapter dedicated to that about flight planning. And then at the end of this webinar, we're going to have the Q&A session. First, about the company, Speaking, who we are. Speaking has been founded in 1995 and is a spin-off of VTT. 30 years ago, 30 years, that starts to be quite a number, but yeah, I haven't been working for 13 years, 13 only. But over that time, Speaking has delivered more than 10,000 devices all around the world. Since 2020, we are part of Konica Minolta. We also have a global presence with offices in the United States, Spain, Germany, China, and also in Finland, of course, where we are located right now, where we have our headquarters. Also, we have a distribution network of all around the world. About the application. The application, they are linked actually to the wavelengths that the camera is dedicated for. So the first one is the VNIR spectral range, between 400 and 1000 nanometers. And then also the NIR spectral range, between 900 and 1700 nanometers. Why I will speak about those two spectral ranges? Because this is where our camera covers, spectrally speaking. So first, about the VNIR spectral range, again, I repeat, between 400 and 1000 nanometers. The first application coming to my mind is related to precision agriculture. You imagine you have a field and you want to monitor if you have a disease, if you have a pest, or if you want to monitor simply the health of your crop. The VNIR spectral range is actually the correct one. Also, you can monitor the growing stage. Is the field or the crop ready to be harvested or not? Again, a VNIR camera can provide you with the relevant information for this type of monitoring. Related to that, still related to vegetation analysis, you can also detect if you have some invasive species. So invasive species meaning a plant which is growing actually where it should not. It could take over, for example, the native species. And this needs to be monitored. And here again, a camera covering the spectral range 400,000 nanometers is suitable to detect like this and to map carefully different types of species. Related to that, you could think right away about law enforcement. You can detect, for example, if you have some narcotic plants which have been planted where it should not, as if there would be planted where it should be, but exactly where it should not. So here again, the VNIR camera can give you all the information that those could be mapped and detected. Also, those people who are putting, like those plants, they like to put them under protective tarp, so they could not be seen from airborne, like from the plane. But here again, if you use a hyperspectral camera, which is looking at the material, again here, those tarp could be detected, giving the hint that something that is hidden should not be there. Another type of application could be related to the environmental monitoring. So for example, water body assessment. Water body, because those water basically absorbs the light up to 900 nanometers. After that, there is nothing which is passing through. So basically here, if you have a camera which is between 400 and 1000 nanometers, you can detect if you have some chlorophyll, you can detect if you have some turbidity or different type of things. Of course, you cannot see through a big column of water, like tens of meters. No, you cannot do that. But already the VNIR camera can give you some very important hints of what you have there, and you can make some really accurate mapping. You can also monitor oil spillage. This is at the surface. Oil stay at the surface of the water, and the VNIR camera can give you an accurate mapping of how it moves with the stream, with the wind, and things like this, with the current. Then, another type of application where the VNIR camera could be important is for forestry inventory. Here, different type of plant species could be mapped, detected, also by the firefighter in order to understand how fast a fire could spread depending on the species which are located. For example, eucalyptus could burn faster than some other species. So here it gives really good hint where to attack the fire. So here I spoke about the VNIR spectral range, but then I will move to the next spectral range, the one between 900 and 1700 nanometers, where we can offer also devices for that, the NIR1. The first application coming to my mind would be related to geology. We all know that, for geological applications, the best spectral range might be up to 2500 nanometers, but already up to 1700 nanometers, you can already map some relevant minerals and ore for your application. So geology could be one application for the NIR spectral range. Also military application. It is very easy to make camouflage material which is mimicking the color which is around, but not the material. And here again, the NIR camera has the possibility to map which material is where, meaning is it artificial or is it natural. So here it is one type of application again. And then, still about vegetation, the NIR spectral range encompasses some important band where you can measure some traits of the plant. So for example, the moisture content. So here, again, the spectral range 900-1700 could be really useful to monitor, again, the health of the growth or simply the vegetation. So here, I was speaking of those two spectral ranges between 400 and 1000 nanometers and 900 and 1700 nanometers. But why I spoke about those ones is because actually at speaking we have product covering those spectral range. We have the AFX10, like this one, which is between 400 and 1000 nanometers, and the AFX17, which is also the same one, basically, between 900 and 1700 nanometers. Those are actually compact all-in-one hyperspectral imaging solutions for drones. They include a camera in there, FX10 or FX17, also a GNSS IMU unit, a microcomputer, and a sensor control board which is making everything working together. So within those packages, which are about 2.5 kilos, then you can put them like this in a drone and you can acquire the data. About those cameras, their line scan device, one is having 1024 spatial pixels per line, another one 640. But both of them, they could be mounted with gimbal or without gimbal to the UAV. Petri is going to speak about that a bit deeper in the coming chapter. Also, an important feature of those cameras is the possibility to have multiple spectral regions of interest. So that means that if you are not interested by measuring the full spectral range, you can select some band only, and then the hyperspectral camera could actually become multispectral camera. You can fly faster, you have also less data to process. Another thing to take into account it is which type of calibration is provided with those cameras. Of course, you have the spectral calibration. There is also the radiometric calibration, meaning that with that you can convert the raw data into radians. And at the top of that, we provide as well the geometric calibration, meaning that with this calibration you can make an accurate mapping, georeferencing of your hyperspectral data. All those calibrations are actually provided along with the AFX cameras. Also, those cameras, they are SMILE and keystone correction. As well, they have a really good throughput for the light. So that means that a lot of light is entering the system, meaning that in fact you can fly pretty quickly or with a short integration time to get a good SNR. Because remember, when you do airborne data acquisitions, your light source is the sun and you cannot put it brighter than what it is. So it is very important that you have a camera which allows you like this to have a lot of light entering the systems. Now we're going to have Petri speaking about different type of features, how to integrate and how to use the FX camera. So Petri, please, stage is yours.
Thank you, Mathieu. Yes, let's talk a bit more about how you practically fly the Specim AFX sensors on board your UAV systems. What I'm going to talk about are these topics, so I'll spare a few words about your possible UAV system choice, mounting. I'll talk about flight planning and the general workflow for the actual flight that I consider is the best when using the FX sensors mounted on the UAVs. All these topics are very wide, so I will be only scratching the surface in all of those, and I'll go forwards rather fast, so you might want to come back to this recording later. So let's start. First of all, the choice of the UAV and mounting. For AFX sensors, any UAV capable of lifting the required payload will work as the most short answer to which UAVs are suitable. The AFX sensors are about 2 to 3 kilos as a payload weight, but it's never a good to choose a UAV which is just only marginally able to lift the required payload. I would strongly recommend at least doubling, if not tripling, the requirement, simply because of the redundancy. So you're better off, your UAV system is not so strained, and you have more controllability in case of any motor malfunctions and so on. Apart from the payload requirement, there is a requirement for the system to be able to fly a pre-planned route. But most all systems these days have this functionality. If not standard, then at least there is a upgrade available in form of a software upgrade, which enables you to put your UAV system to fly a route. Manual flying doesn't really cut it because the AFX systems are starting and stopping the collection based on the location. So you need to hit a certain waypoints reasonably accurately. And this is easier done when you have an automatic route flying capability. I recommend hexa or octocopters if we are talking about multi-copters. Of course, there are fixed wing options as well, but those are a bit more complicated. You have to be a seasoned user already if you plan for those. I don't recommend quadcopters. And what these words mean, hexa and octocopters, those are 6 or 8 motor UAVs, whereas the quadcopters are 4 motor multicopters. This is again because of the redundancy. If you have only 4 motors, losing one means that actually you lose 2, and the remaining 2 typically they don't suffice to keep your payload in the air, and even less keeping the system controllable. So the crash is for sure is assured. So hence hexa and octocopters are better off in that regard. But I personally consider the operator training far more important than whatever brand you happen to choose. There are more than 1,000 of UAV manufacturers in the world today, and it's more about where you get the best support and so on. Dedicate your operators. Don't underestimate the requirement, the challenge, because the air is the most demanding of our elements. And the operators, obviously, they need to do due diligence, the airspace, ground risk, They need to register in most countries and so on. You get this information from your local CAA. Don't just go flying, check it open, please. It's not good for our industry or anybody. And above all, gain confidence. Fly a lot before you put your valuable sensors on board. Just empty or with dummy weight, to gain confidence and to really to learn your system, how it works, what are the problems. I consider those last points as more important, once again, than the actual brand that you end up with. Let's go forwards. Fixed mounting, pros and cons. Fixed mounting is lowest of weight and the cost, but obviously it's adding a little bit more blur than the gyro stabilized mountings. They don't correct for the platform tilting during the flight, and the fact that these tilts and crabs not getting corrected means that you would need to plan your project with a little bit more side lap. I would say more than 30% would be a good starting point. And because you need to use more side lap, it means that you need more flight time to cover an area. I recommend the Dampertsen mountings. They are from Hungary. You see one in the image on this slide, and they work very well, and they are adjustable regarding their springs, meaning that you can vary your different stiffness of your mounting depending on what your vibration levels with your particular UAV platform happen to be. Then the gyro stabilized platform. They are giving you the best ground sampling distance, meaning / spatial resolution, because they don't just move the sensor, keep the sensor vertical, but they are also the best vibration damping choice usually. And yes, the best nadir leveling, and it does correct for the crabs and tilts, so you can go down on your side lap requirement. The downsides, cons of the gyro stabilized mountings are that obviously they add weight, they add cost, and complexity. You need to learn to use it, adjust it, choose multiple different modes, check for the center of gravity, and so on and so on. And obviously this added weight is reducing your flying time. They also let the antenna level arm fluctuate. I'm not going to the deeper of that now. And they may actually increase your IMU drift. The same applies here. I'm not going to deeper on that, but these are the things that you perhaps would like to consider when choosing between these two choices. Let's go over to the flight planning. Basic flight planning idea of a hyperspectral sensor, the AFX, is the same as most others, with a couple of points added. First of all, you really are well off prioritizing the SNR, the signal to noise ratio, over resolution. This is a bit counterintuitive. Usually everybody wants the maximum spatial resolution. But with hyperspectral sensors, remember that it's not about spatial resolution, it's about spectral resolution. We fly these sensors. And high spectral resolution means that you are sometimes strapped off the natural illumination. And if you don't get good enough signal to noise ratio, you have too much noise to separate very fine spectral features from each other. So prioritize the SNR, don't max out the sensor. This means don't push it on to do too high frame rates or too low binnings unnecessarily. Plan north-south if possible, for a couple of reasons I'm coming to later, and plan for the side lap according to your mounting system. The side lap depends on a number of factors. First of all, the wind. So as you can see from the left, if you have a lot of crosswind, then the width of your swath is getting less, and therefore the side lap is reducing. And again, if you are having a fixed mounting, then any tilts and crabs are also going to risk gaps between the flight lines. Solar window is something you certainly should consider. The solar window meaning from which time to which time during the day you can actually collect, and that is everything to do with the solar angle, so sun angle from the horizon. 40 degrees is the kind of good minimum from the point of view of atmospheric correction. You can go down to 30, but the illumination will drastically start reducing when you drop from 40 to 30. I realize this is a problem in the northern or extreme southern latitudes, but that's how it is. Also, the reason to fly north-south is to do with a thing called BRDF, or bidirectional reflectance distribution function. And in short, it means a different kind of illumination on left to right side of your swath. And you would ideally want to collect or align the line heading to the direction of the illumination. Obviously, this is not always possible. So the best average is to align north-south, because then the illumination is in the line heading during the noon. Whichever you do, try avoiding the situation on the right, where the illumination is from the perpendicular to the flight lines, because then your BRDF issues are at maximum, meaning that your spectral albedo, left and right side of the center on your swaths is very different. And if you are doing mosaicing, this will be very evident unless you correct it algorithmically, which is possible only up to a certain point. Another reason to align your flight lines north-south, if you are flying some other headings, like on the right, the file size absolutely explodes. Although it's not only this image which is contributing to the file size, but also the black pixels within the window during our computer windows. On the left is a north-south line, and as you can see, it's a minimum in size in comparison. Flight planning workflow, you should create two different KMLs. The first one for the UAV flight path, and the second one for the start and stop, or actually the record lines for the AFX 10. These two KMLs go to two different places. The UAV flight path obviously goes to the UAV autopilot for the automated route following flight, and the AFX 10 KML goes to the AFX 10. More specifically, the AFX is Web UI, which is turning the sensor on when you arrive to the start of those lines and turns it recording off when you reach the end. Always remember to actually fly in the same direction you have created these AFX on-off KMLs when you are creating the flight path. So how it might look in practice might be something like this. This is the typical bore-side cross flown with the typical specking sensors. On the left, you see these on-off flight lines, 3 of them forming a cross. And on the right, the actual flight path of the UAV for the autopilot use is drawn on top of those flight lines, exactly on top of those flight lines. And as you can see, the starting point is here. So the autopilot is flying the route, and the AFX, quite separately from the UAV autopilot, is starting and stopping the sensor as required. Just quickly running through, so the flight planning workflow, you need to decide the area delimitation, ideally create a KML of that too. Check the air risk, ground risk, and site facilitation of this area, meaning do you have some controlled airspaces? If this area is close to cities, typically you have controlled airspace all to the ground, and that is something for the operator to take care of and make sure that it is allowed to fly where you want to fly. Ground risk is there, meaning is there habitation under, a lot of parking lots, a lot of full of cars and so on. Site facilitation, can you actually access the start, the takeoff point and so on. And then you draw those lines with the Google Earth using Path Tool as described on the earlier slides. Don't start or end the turns right in the beginnings and ends of the on-off lines. Give a bit of lead in and lead out for a number of reasons. And avoid turning to the same direction between the consecutive flight lines for the benefit of IMU operation. Then you decide your flight planning, the AFX configuration regarding binning and frame rate, and obviously also the flying height, because that determines the GSD. And finally, once again, give a once-over regarding any problems in the area on the flight path, terrain, elevations, obstacles. Are there masts that you might hit? How high are the trees? It sounds like a no-brainer, but trust me, it isn't. I've seen a seasoned crews to fly to the hillside when they thought that the Earth is flat. So be serious about this one as well. Minimum ground speed. Well, your AFX is equipped with a single antenna GNSS IMU. And IMU requires alignment, and it's doing it with the aid of the GNSS. And GNSS is unable to give you a good heading unless it is moving at minimum of 5 meters per second. Therefore, every flight should start and at times also end to the alignment run. And that has to be at certain speed. And the whole flight should also be carried out at least 5 meters per second ground speed, because otherwise the IMU alignment regarding the heading starts deteriorating. And that in turn means that there is a certain minimum regarding the frame rate and the altitude, certain maximum regarding the frame rate, depending on the kind of a terrain you fly over. Let's say it's a medium reflective, let's say a vegetation, green vegetation area. My recommendation would not to cross the 75 hertz. Unless you bin more, unless you accept non-square pixel. And this means that your minimum flying height over ground is 50 meters. Again, unless those relaxations are done. How the actual flight operation goes? Well, first of all, you take off. Oops, let's go forwards. You take off, you gain the altitude you have chosen, and you do an IMU alignment run, first of all. This you can fly manually. You can, of course, do it automatically, but just as well you could do this manually. So what you need to do is to do maximum acceleration in your chosen direction up to above 10 meters per second. Continue that 10 seconds. Make a maximum braking and continue backwards the same direction that you came from, also above 10 meters per second, at least 10 seconds. And when you've done that, you've aligned your IMU and you can commence your automatic flight route following and let the UAV start automatically to head and navigate towards the first AFX flight line. Here's the first one. AFX is collecting it. It's turning to the next one and next one, all automatically. And notice the turns here are planned to the different directions. First turn being left, then right, then left again. And this continues until the end of your mission, how many lines ever you happen to have. In this case, you have only 3 because this is an example of the ball sighting, once again. And when you're done, you can return to base. But if you want, and if you have a possibility for the PPK processing of your GNSS IMU trajectory, meaning post-processed kinematic. You would need to have another software solution from the Planix called a POSBAC UAV. And when you do PPK, irrespective of the workflow and the brand, it helps when you are aligning the sensor in the beginning and also in the end. Because one of the reasons why PPK is the most accurate positioning method is that you can process both forwards and backwards. And if you do backwards, you need to start from the alignment. And after you have done this, then you fly back to the base. It's exactly the same if you fly a standard mission non-bore side. It's kind of an area coverage flight plan, or if you fly, let's say, a corridor survey. Doesn't matter. The idea is the same. First takeoff, then alignment, then you fly your lines automatically. And if you want to fly, if you have a PPK processing workflow at your disposal, you ideally would do the IMU alignment in the end, and then return to base. And if you don't align your IMU properly, this is how it looks like. The base image here is from Google Earth. It's geo-rectified image, and in the middle you see an AFX line flown with poor IMU alignment. I'm sure you can see that. You can see the same. This is a parking lot of a football field, and these driving parts do not align to the actuality. They are off. Now this is because of the IMU alignment. It's not about the AFX sensor itself. It is about the APX15 GNSS IMU alignment problem. These white ones here are the actual flight lines which were planned, and the UAV flew along the line reasonably well, but the IMU hasn't been aligned properly. And the reason here in this case was too slow alignment speed. Here's another view of the same. As you can see, the alignment is wrong, and also you have an additional wobble. This is also something that you get rid of when you align your sensor properly. Also, the PPK method is helping here tremendously, because then you get the double IMU sampling rate available. And my time is up. Thank you for all the listeners, and let's hear some questions.
Welcome back. So we are back here about this. So now if you would like to contact us, if you would like to make a demo, or if you would like to arrange a demo, or if you need to get a quote, please do not hesitate to send us an email at info@spekim.com or visit our website at spekim.com. We will be very happy to come back to you. And now we are ready to move for the Q&A.
Thank you, Petri, for this presentation covering really, as you say, the scratch, but the most important part what to take into account really when you want to acquire data with a UAV. So really, thanks a lot for your speech. And then let's go through the questions. So I see we're having so far 3 questions. So I read them and then we decide, how we contribute to try to answer together, right?
Good.
So just to confirm, under the most ideal circumstances, you want to organize your flight path directly aligned with the sun and not perpendicular to it. You had a slide about that, Petri. So you were really clearly showing that you need to fly to have the sun in this angle in front of you, but not sideways at all. So maybe you can just jump on that as well.
Yes. Well, it's mainly it is for minimizing the BRDF.
That's
bidirectional reflectance distribution function, and improving your mosaicing result and making your analysis of your flight lines easier. Because if you have a lot of BRDF, you can still analyze and get your detection result from your lines, but it's more processing because the left half of the image looks different than the right half. It's the same as if your laboratory illumination is poorly set. You get different looking results on the different pixels. It's basically the same here. It doesn't prevent your work, but it makes it harder. There's more processing.
But here it's wonderful you answer, because actually it raised me like one thing you were saying, like for example, when you fly like this with the sun in this direction, thinking like you need to minimize the size of your data, it means that you are flying towards the south, like north-south. So
Yeah.
first of all, that's a good thing. And then we go actually to the third question, because you were touching the point of the BDRF or BRDF, the bidirectional reflection function. So here we had a question about which tool do you use actually for the BDRF correction. Is it possible to integrate with the pre-processing workflow? So here, can you explain a little bit how you can take that into account in your data analysis?
Yes. Well, this is about the spectral albedo. So it is a quite complex thing, but it's about its geometry. So typically it's corrected algorithmically, and there are tools for it available. Some of them, I believe, are open, but then you have a commercial software called AdCore 4, for example, as well as DrawCore, which have tools for correcting or at least minimizing the BRDF, depending on if the data is such that you can correct it, you can minimize it. And this algorithm is taking in account things like illumination, azimuth, illumination elevation, your ground slant angles and directions, your flying altitudes, obviously a lot of parameters to correct for these geometry differences. And then it is increasing the albedo where it is required and reducing the albedo where it's required in order to even out the whole swath, the whole image.
Thank you for your answer. Then we have again a participant who is asking, like, do you have any recommendation for any phone apps that are able to provide an accurate reading of the sunlight angle?
SunCalc.
What? Please repeat. I'm quiet.
SunCalc.
SunCalc. Okay, thank you.
I'm using that in my phone. It's great.
Okay, so perfect. So SunCalc. How to collect the downwelling irradiance data for radiometric correction in an AFX flight?
Do you want to answer, or me?
Oh, please go ahead.
Okay. Well, there's a bit of a history here. The Specim used to have a so-called FODIS, fiber optic downwelling irradiance sensor, for many years. I think more than a decade. Specim was delivering sensors with the FODISes, but there are so many issues, just physical issues regarding the FODIS, that it was struck off the current line of sensors. And nowadays the recommendation is to use a separate FODIS sensor, the downwelling irradiance sensor. They are available and they are very good. And then you would include this in ENVI, this recording in ENVI. But if I just shortly touch the problems there are, as they are physical problems. The first problem is that when you collect irradiance in the sensor, you are collecting it at the flying height, not at the ground level where you really would like to. That is the first problem. Second problem is that if you have a low sun angles, less than 40 degrees or even 45, then the problem is the field of view of your irradiance sensor. This is why some remote sensing entities like the DLR have a this kind of very complicated FODIS sensor on the roof of their aircraft, which is actually gyrostabilized and turns towards the sun, and it's following the sun during the flight. You can imagine what kind of expense and a complexity this is to have something like that. But it's for research, so it can be justified. But you flying a UAV where you want to minimize the weight on board as well as the cost of the system, you can't really have a FODIS on board, and it doesn't make sense either. Especially as you fly a UAV project, it should be easier, way easier for you to actually walk on the terrain that you want to collect, and it makes much more sense to use a separate let's say, handheld irradiance sensor. They are available, and I think Specking can help you with those.
And you remember, like as well, when we had the FODIS, which was implementing, it was actually eating some of the pixel which were on the side of the sensor.
Yeah.
So that means you were reducing also your field of view.
Non-symmetrically, so one end.
So
you had to consider that you have more pixels on that side than that side, and it was making it complicated.
Thank you. How would this rectification and triangulation be done in areas with hills? Well, I remember that you have been showing to me like a lot of data where we had to fly over hills, and then they were looking really like a funnel sometimes, you know, your flight line.
Yes.
So I think it was really important here to take into account the overlapping between the flight lines that you needed to have, like you mentioned, 25 to 50%. But I think in some cases, when you have the hills like this, you need to take even more like this into account.
Yes. Now, first of all, what this is based on is a digital elevation model, DEM, DSM, or DTM. And in the case of hyperspectral sensor, my recommendation would be to seek a DSM. They are less available. The difference between a DEM/DTM versus DSM is that the DEM is a bare ground model. DSM has all the houses and the trees, on top of which you obviously see. You don't see necessarily the ground under them, but you see the tops. So you would like to have your georectification done on what you see, the tops of the trees, the roofs of the houses, and DSM gives you that. That's the first point.
But
and
I think
second is the flight planning.
If I can say quickly, I think the DSM, you can get it as well from a LiDAR, right?
All of these you get from the LiDAR. DEM is the most rudimentary, basic, last point LiDAR digital model. DSM is the first point model. And DTM is a product which is typically done from the DEM by geomatics companies. They are adding some things there, like terrain features and so on. But the second thing was what you touched, Mathieu, the flight planning. There are flight planners which are taking the DEM in account. For example, completely freely available DEM sources like that of like SRTM, which is the Space Shuttle Collected Global Digital Elevation Model. That is a good starting point. There are more accurate ones, let's say higher resolution ones, but this is a good starting point. And when you do your flight planning, meaning you put your flight lines on this digital elevation model, then this funneling, as you very well mentioned, starts happening, and you can adjust your sight lab of your flight lines, including this funneling and narrowing and widening of the swath, so that you remove any gaps. And typically on very high peaks, you need to put your lines closer or even add a line in between to prevent gaps. This is a higher level of the flight planning.
Thank you, Petri. So now we have a question: which tools are used for building mosaic of line scanner data? So now we are out of the AFX world, so I will take that one. So here, basically, it's a software feature. So basically, you know, like in Envy, you can make like mosaicing in our data processing software, which is as well inside. You have the possibility to merge some part of the data together as well to make some mosaicing. So here, well, it's more software features than a technology features.
We add Envy and AdCore are doing it.
Yeah, exactly. Yeah, I did not say AdCore, I said Envy. Yeah. Will you make the camera AFX possible to control from the UAV autopilot? Having to make 2 flight planners is always a hassle. Here, I understand from the usage point of view, but then you have to think maybe as well from the development point of view. It means that we will have to be like compatible with all the FMS from the different supplier of drone which are available on the market, and we simply can't do that. Okay, so can you use your own lighting? Is it laser scanning? Is that a possibility? I'm not sure here if the question is still in the context of airborne or UAV application. Petri, have you heard about like laser scanning like this? For illumination, I mean, can you make your own lighting? So, but then
I've been even doing testing of that. I've had clients who have wanted to illuminate the area. Well, that wasn't a airborne, but that was a terrestrial scanning of a mine wall So we tested using halogens, and I have to say maybe it can be done, but it's very challenging to do it. You have to have very, very good halogen light sources. And when we are talking of mining, currently most light sources are LED, and that just doesn't work at all. So it's very challenging. I'm not saying it's not possible, but it's very, very difficult.
When we use artificial light, you know, when we go on the field or when we use a system like in a lab or when you have greenhouses, for example, but from an airborne perspective, I haven't seen.
Short distances, yes, absolutely.
Yeah. Can we use, that's a question for you here, completely. Can we use a ground speed of 4.5 meters per second with the AFX10?
Yes, you can. You just have to bear in, then accept the possibly reduced IMU and IMU heading. Now, what I would do if you absolutely have to fly 4.5 meters, do it, but align at least 10 meters per second and limit your flying time and maybe do extra alignments in between. Whatever you do, I would recommend you to have a quick QA/QC facilities with you in the flying field, meaning you fly a flight with the 4.5 meters per second and alignment routines, and then you quickly process to rectify your imagery. I can do it in 5 minutes in just sitting in a car when I fly with the AFX. So you see if the georectifying result is satisfactory to you. If it is, great, it was fine. If not, fly again with, let's say, shorter time interval between two alignments. That's what I would do. And also I would bin more, meaning
to increase the SNR.
Yeah.
Line scanning is too complex with so many constraints and prone to incorrect georeference capture data. Snapshot technology is the way to go. That's the point of view. Is Peking working on a snapshot model with a high resolution capability? Well, to answer the question, no. But here I would like to challenge when I hear it's too complex and then it's prone to a lot of issues like incorrect georeference capture data. Here I disagree. I disagree because if you have a snapshot camera, so it means that your spectral resolution might not be the best, the spatial resolution might not be the best. Also, you need to have a fly, you need to have something which is moving your camera like this to keep basically the field of view of the camera constant while you're acquiring the data. And also our camera could be used in different type of context. It could be at the top, you know, on a rotary scanner, it could be on a conveyor belt and things like this, so prone to many type of application. But maybe here, Petri, you want to complete as well.
Yes, I will welcome anybody who says that a snapshot camera is a better choice to a face-off with me flying AFX, and let's compare the data. That's all I'm going to say.
That's wonderful. I think the meeting is taken, right? You told a lot about IMU drift. Did you also experience drift of the gimbal, difficulties to keep the nadir view? If so, do you have any recommendation to deal with the problem?
Yes, I've seen it. And this is about learning the gimbal and having a good high quality gimbal and learning what it likes and what it's not. Sadly, these are consumer components, the gimbals. They are not military standard, so they do have the drifts. They are also based on their own IMU. Now, the best thing would be that there would be a model which would accept the corrections from our sensor on board IMU, in this case APX15, because its chances are it is better than usually used in the gimbals. They do drift indeed, but the same things apply. Give it a little bit of movement and use a good flying procedure, meaning no rough turns. And then you choose between maintain the flight planning heading or maintain the flight heading. There are these kind of different modes that you can choose in them, and some combination of those will give you the best results, but it's impossible for me to tell what it is because there are many different gimbal manufacturers, many different modes.
And I remember you mentioned once, like when you mount the camera, the AFX on the gimbal, you should be careful that actually the gravity, the mass center somehow should be below, of course, to keep, you know, low and not to put it above the mounting point so that actually naturally it will tend to rotate.
Yes, absolutely.
Because people understand what I mean here.
Yeah, gimbals have a limited motor power. So you will help them. Ideally, you would like to have your rotating mass center of gravity exactly at the center of the rotation. If it's difficult to find and therefore slightly below it is usually the best results. But as you said, absolutely not above the center of rotations.
Thank you very much for this very interesting. So for us new in the topics, do you have more example of environmental monitoring and product like the slide with the chlorophyll, the phycocyanin, and also like total solid contents we showed at the beginning? I would say yes, we have more slides, but here I would invite actually that we will come back to you, or please come back to us at info@spekim.com, or even to Petri, like with Smart. Can you repeat, Petri, by the way, your email address to the people?
Petri.nygren@smaps.fi. So Petri.nygren at smaps.fi.
Actually, Harry told me that he put it in the chat, so it's perfect. So yes, if you contact us, we contact you back. We will give you more slides. That's not a problem. Okay, so the next question. Do you have a recommendation on software option to work your data? And thank you. Well, I would say like for airborne data, 90% of the customer I know, they are using Envy. So this is really like the software like which is used worldwide. If you want to use different data, like if you don't want to use UAV data or not airborne data, then you have other software available. We have our Insight, for example, or there are like some other one. You can make your own data analysis with Python, also with MATLAB. But if we are really in the context like this of airborne application, Envy is the one coming to my mind. I remember as well ERDAS, but I do not know how much it is used nowadays.
ERDAS imaging.
Yeah.
This belongs to the category of the GIS, the Geographic Information System software, and there are several in the market. Typically, they fall short of Envy capabilities, or they are not designed for spectral information. They can do typically they can do a simple NDVI and so on. They can work with RGBI, a few bands, but they don't have the analysis functions, and they sometimes struggle with the amount of bands. Quite simply, they are made for geomatics, making maps, treating with LiDAR DEMs and RGB imagery and ortho imagery. That's what they are for.
Thank you. Oops, it has been jumping on my screen. Which software do you use to collect the geo data from the drone to the computer? And we have different reports for geology. So I need to read it again. Which software do you use to collect the geo data? I understand geo-coordinate or geology, because after it's asking for geology. From the drone, I think it's geographical coordinate to the computer, and we have different reports for geology. Well, if it is a question, as I understand it, so Petri, you may understand differently, but may I understand it for the geographical data when you fly, if you want to georeference, we have in the AFX, the GNSS IMU unit, and here you have actually a navigation file which is acquired at the same time as the hyperspectral data, and there is a synchronization between the frame which are acquired as well with the geographical data. And then we have actually our software Caligeo Pro, which is based, it's made by Spekim, but you need to have a root of Envy to use it. And here you can convert the raw data into radians, but you can also georeference your data.
If I may add, yes, it's really a topic of a separate presentation, but in the shortest possible form, there's a Caligeo Pro for the pre-processing. There are a couple other choices, but that's my favorite, the Spekim Caligeo Pro. This is turning your raw DN data from the flight into georectified radiances. After that, if you want to go to reflectances, you apply one of the several possible atmospheric correction software, and after that you are having a data in form of georectified reflectances. After that you go to the analysis stage, which most people use Envy for, with possible their own adaptations in IDL.
just the same questions they were asking about report for geology. I think like here it's more like application to convert the spectra into like, you know, like a geological map. So here, for example, in NV, you have also the USGS library, which is included with the software, which would be really useful by running like, you know, like likelihood algorithm to compare like the spectra obtained with the library, but that's then it's another topic.
Yeah.
Autopilot control camera. Most autopilots can be made to send a voltage pulse, or the cameras can receive that to start and stop triggering. Will really help flight planning, especially in hilly environment where you then can use the terrain following of the drone. Please consider this.
Yeah. Can I?
Please do.
Yeah. Well, yes, everything is possible in engineering. I know what you mean, and yes, it would be extremely useful, but then we would the specking would need to lock to one particular autopilot type, whereas the specking has to provide a sensor for a wide field of different customers, most of whom may not have been using UAVs before at all, even less doing modifications like this. So yes, it's possible, but you would need some integrator to do it. Specim has to concentrate on creating a best possible data for spectral analysis for the wide field of different kind of customers.
So then I think the next question is kind of making echo to this one. Does AFX 1017 have, or are you planning them to have some API possibility to trigger image line collecting on demand dynamically during flight to relaying, no, not the relaying on pre-configured flight path start stop points? Well, not really, but okay. How do you convert the,
May
you want
I?
to say? Yes.
Existing AFX can be rigged like this, but you need to do it yourself. You
Yes.
add a data link, and that means you are having continuous Ethernet connection from your laptop on the ground via data link on the flying AFX, and you can just turn on and off with your finger, or if you want to do some batch software, you can do it there.
But that's an option we don't propose anymore. We had
It's
it in
not
the
from the
past.
spec in.
Yeah. Yeah.
So you need to do it yourself, as I said.
Exactly. Yeah. How do we convert the AFX HSI image data from irradiance to reflectance? Well, so basically, I think ATCORE is one of the good tools to do this kind of thing, atmospheric correction. In NV, you have also, if I recall well, Flash, who is doing that, and there is Quack as well, which allow to do these kind of things. So there are softwares available for this.
Also DrawCore, remember DrawCore, it's really actually better than ATCORE for these altitudes that we operate with the UAVs. So RESC is the company, DrawCore is their software product made exactly for the kind of work you would be doing with the AFX mounted on UAV.
Do you have experience with a hard mounting or vibration issue? You touched that at the beginning of your presentation with the blurring. How do you treat them in post-processing? Well, then, you know, if you have the blur from the beginning, there is not that much you can do.
Yeah, well, you process it exactly the same, and you suffer the consequences.
Exactly.
So, and the hard mounting works. I've done it, and at times the hard mounting is my preferred option if I have a poor damped mounting, because sometimes if I can't vary the damping, then chances are that the resolution is worse than at the fixed mounting. So you might need to try it. On my tests, usually rather hard damping is better than too loose damping. And too loose damping is worse than fixed, completely hard mounted damping. It's the same thing as with the crewed flights, with the bigger spec-in sensors. If you have some kind of damping elements, the results might be worse than just hard mounting to the floor.
Okay, so now we have the last two questions, and actually they are linked together. And I think we're gonna end like soon because it's already more than an hour. So just those two last one, actually, they are giving hints about what could be the theme for the topics for the next webinar. So one is like, thank you, excellent presentation. I really, Petri, I would like to thank you for that. Do you think there will be webinars on data processing, CaliGeo Pro, NV, and data analysis in the future? So that's one thing, that's one request. And are you planning any workshop on HSI data processing? So basically, this is a kind of together. So in the past, we had actually like a webinar about how to use our image processing software inside for data analysis, but that was not dedicated, I have to say, for airborne use, but that's something that maybe we can keep in mind for future webinars. So I don't lock the door for that. So that's something we can take into account. Yes, thank you, Petri, again for this really nice presentation. So now we are going to go through actually the question, and we have quite a lot, I must say, so that's great. We have a really active audience. So I suggest, Petri, we just go through and yeah, so maybe we start with the first one. Are there any plans to extend into the mid-infrared, for example, 3.1 micrometers? So maybe I will take that one. So for the mid-infrared, actually we have a sensor. We have a sensor, but let's start from the other side, sorry. Extend up to the 3.1. No, we have the AFX17, which is like up to 1.7 micrometers. In the past, we had cameras up to 2.5 micrometers, but then we did not go further than that because then you have issue, for instance, due to the atmospheric absorption band. After 2.5 micrometers, you start to have oxygen or even CO2 or different type of gases which absorbs the light. And then you don't have actually light which is reaching the surface of the Earth coming from the sun because it absorbs, you know. So up to 3.1, no, because you have absorption feature between 2.5 and actually 3 micrometers. And I saw there was a question a bit further away. Is it possible to extend into mid-infrared without some IR source? So we have at Spekim an FX50, which is between 2.7 and 5.3 micrometers. But for the reason I was explaining, so first, the illumination is an issue. And the second thing is that this spectral range is a little bit tricky because at the beginning of the spectral range, you have the reflected signal, which is dominating the emitted one by what you are looking at. But then when you go to the end of the spectral range, around 5 micrometers, this is actually the opposite. And in between, it's a kind of, I'm used to call that a thermal porage, where you have the reflectance and the emission, which is actually mixing to each other, and that starts to make the things a little bit tricky. We are aware that there is like sensors, which is covering the mid-infrared, but there are issues. So Petri, do you want to add something here or we move to the next question?
You were quite conclusive, Matthew, so let's move. Thank
you. So what does crab mean?
I think I explained that. So it's a drift. So it's the heading changes. Regarding which gimbal would you recommend?
Yes.
Well, DJI makes very nice gimbals, and they're kind of market leader. And those what I have most experience of. They work great. Not completely 100%, but the best I've seen in this size. But it's those points that I mentioned. So it's added weight, cost, complexity, but they are good gimbals.
Thank you. Does the camera calibrate data? I would put it the other way. The camera is calibrated. So because the camera is calibrated, then you get calibrated data. When we are talking about airborne systems, there are several types of calibration. And actually, that's maybe something we could speak a little bit. So there is first the spectral calibration. So it means that you are sure that the spectral feature you are observing are at the right place. Then there is a radiometric calibration, which means that here you can convert the raw signal into radiance with, like physical meaning. And then there is a geometric calibration, which actually tells where the pixels are located along the swath. Do you see anything else, Petri? Or
well, there's also the SNR measurement, and there is the spectral resolution measurement in terms of full width, half maximum. And then those mentioned here, that the 5 calibrations are factory calibrations that Spekim is offering you. But then there is what I mentioned before, the bore side calibration. It's calibration also. Unfortunately, it cannot be done in the lab. You really need to fly it. And that is the attitude angle difference between your sensor and your IMU.
Perfect.
And hey, one more. The dark current. That's a form of calibration as well. Removal of the electro-optic noise from the data. That is what the sensor is doing.
Well, you're right. Every sensors, they have some noise. So here we have a shutter, which is actually included within the AFX. And then by closing, you can measure what is the noise of the sensors. You are right. Here we have a question. Do you want to avoid sunny day? Petri, did you really say you wanted to avoid sunny days?
I don't think so.
No,
If
I
I
don't
did,
think
I apologize, because the opposite is the true.
yeah.
You want the sunny days. You need to look ahead in your met reports, weather forecasts, so that you want to grab the best, meaning the most sunny days for your collections. You can collect underclouds, but it will limit your SNR.
Well, you have to think as well that a cloud is water. So basically, like having a cloud is like having a filter full of
Yeah.
water with other absorption. So yes, no,
Excellent addition.
you don't want to have cloudy day. You want to have sunny days. So is it possible to extend? I already answered. Then, does the SPECIM have experience imaging vertical facades, such as in open pit mining? We're encountering several issues, especially using gimbal, which we will need 90 degrees tilt and 90 degrees roll in order to have the sensor imaging in vertical lines and the drone flying in horizontal flight lines. Secondary, we are having difficulty in mosaic the image because Caligeo correct the yaw, pitch, and roll only in map projection, even when using a digital elevation model.
May I take this, Matthew?
Please go ahead.
Because I've most certainly done exactly this, although not from UAV, but I've done it from the tripod, and I have used Caligeo Pro to process them. It doesn't matter. Caligeo Pro doesn't really care which direction the sensor is pointing, as long as it has an information of pixel to sensor distance. And there are a couple of ways you can give it in the Caligeo Pro. You can either give a fixed distance, which would then be considered a height, or you can give it a DEM, which is a vertical wall, or let's say a wall, invisible wall behind your, let's say, a rock face, and it will georectify. We've done this kind of projects, multiples, in a open pit mines. I can tell you it works.
Okay, thank you. So yes, what I had in mind, it was using as well a rotary scanner, something like this, but it's exactly what you say.
But it's actually even easier with the UAV, because you have a movement and you have a aligned sensor. What we had with the tripod, we had to first move with the car to align the GNSS IMU, then stop, and then scan. And it was based on very high grade IMU, which means that it has very slow drift rate. So it remained accurate long enough for us to take the scans of the rock face. I can tell you this works, and Philippe, you are thinking along the right lines. This technology is definitely usable for rock face imaging.
And then Philip actually added that they plan the flight using UGCS. I have to say, I don't know myself what is UGCS. Do you know, Petri?
I don't actually. I don't know what it is.
So no, me neither. So here, sorry, Philip, I cannot help with that. Then the next question. Don't the AFX IMU use electronic compass to compensate heading drift?
It does, actually. The AFX has the APX15 GNSS IMU, which does has an electronic compass. Problem is the electronic compasses are not accurate enough for the requirements of a georectification at this accuracy level. They are assisting with the alignment process, but they are not accurate enough alone.
Can the high acceleration alignment step be swapped for a few figure 8 maneuvers?
Well, I can hear from this question that Marcel has been aligning IMUs before, because quite a few brands indeed ask for figure 8s, and quite often it is an airborne IMUs. And yes, we often fly figure 8s with the crewed aerial survey aircraft to align the sensors, but the straight line alignment principle is based on the Planix instructions. When you purchase the sensor, the AFX that is, you will get also the Planix information And the alignment procedure I have defined in the presentation is one-to-one a Planck's recommendation. So I would suppose you can do figure eights as well, but it's not according to the Planck's instructions.
Thank you. What sensor do you have that cover 2000 to 2500 nanometers for UAVs? We don't have a sensors for UAVs that covers between 2000 and 2500 nanometers, but we have a camera. We have a sphere camera, which is between 1000 and 2500 nanometers, and it is based on an MCT detector. So for this type of spectral range, I would use an MCT detector. The camera can distinguish marijuana plantation from other plants. Yes, we have seen actually some of our customers who have been flying over like plantation, and they have been able to detect like narcotic plants, marijuana, coca plantation as well. So yes, actually I think it was flown with a camera covering the spectral range between 400 and 1000 nanometers, because this is where actually you can really nicely separate the different type of plant species. So yes, for this type of application, hyperspectral imaging is very useful.
May I add a few words?
Please.
This application is one of the early ones that the specking sensors were ever used, and they are being used by authorities tasked with this kind of things, and those authorities typically have the second one of the two constituents of you being able to do this. They have a spectral libraries with these different illicit plant species mapped in the database very, very carefully, very precisely. Another constituent that you need is a good SNR, as discussed. You need, because the vegetation, different plant species have their spectral features very close to each other. So you need to typically recognize a very fine differences between the different plant species. And the key for that is to make sure you have a good signal to noise ratio, minimal noise in your data. And you also need to do a very good overall process workflow, processing it. But it's been done for 25 years. You just don't hear about it because it's police and militaries doing it.
Yeah, I have seen old slides, from speaking material with actually this type of presentation. So this is pretty old indeed. Is the AFX push broom or snapshot? Which approach is best? Well, of course, Pekim, we are making a push broom camera, and this is the best. So why it is the best? Because you can have a high spatial and spectral resolution at the same time. All the bands acquired at the same time, so you don't need to have a really stabilized platform following the flight, direction. And it can be used in different type of context as well. So you can use it for like industrial application, lab application, airborne application as well. So there is this kind of flexibility of this technology with the push broom approach. Okay, next question. I am in the conservation industry and we deploy drones onto large nature reserve here in Southern Africa. The conservation teams are very interested in doing vegetation survey with these sensors, but little has been done in the past. And the areas we need to cover are upwards of 20,000 hectares, which lead to problem with data processing and file size. I think, to be honest, 20,000 hectares, Petri, you have been flying over even bigger area.
Way bigger. But these have been way bigger projects. There's no limitation, Craig, regarding using this technology for 20,000 hectares. The question is, do you absolutely want to force it being done with UAVs? Or are you fine using a crewed platform? Because that size is already the domain of a crewed aerial survey aircraft. And Specking certainly has sensor models for that application. And yes, like Mathieu said, I've been involved with dozens of airborne campaigns with hyperspectral sensors, and they have been bigger than 20,000 hectares. Not a problem anymore.
And I think in terms of data processing nowadays, like computer power allow you actually to have large memory, like RAM memory, so you can actually process large data size. Large data set, sorry. So I remember, like, for example, with Envy, because for airborne application, I'm using Envy as well. I don't manage to crash it, to be honest, even if I have a data set which could be like 10 or even 20 gigs. So I think this is not a problem anymore.
Nope, can be done.
Then the next question, for survey of plastic waste on coastline,
Sorry, you
was the
missed one, I think. No, sorry, it was
no,
an answer. Go ahead.
that was
Sorry,
an answer.
sorry, Matthew.
Yeah, no problem. For survey of plastic waste on coastline, what will be the best camera to use at a minimum of 32-meter height? Is it enough to look at small pieces of plastic as large as bottle caps? All right, so here's the difference. So if you want to monitor like plastics, first of all, I would say the good camera for that is between 900 and 1700 nanometers, because this is where you have the most relevant spectral information. But the thing that I wonder is, like you say, coastline, meaning mixed with water, or you mean really like, for example, on the beach, for example, on the rock? In the question, I understand this is more like on the beach, like on the rock. So here I would say like maybe an AFX17. And then you are talking, if you are located at 32-meter high, I don't know exactly. I think the pixel size will be close to be 5 centimeters. I just out of my head, but I think it's about 5 centimeters. So if you want to monitor a bottle cap, you will have basically a single pixel, and most likely it's going to be a mixture of the cap with the background. So the detection might not be perfect. You might detect there is an anomaly in the sand, but to detect that it's going to be a plastic and which plastics might be tricky.
I have a spreadsheet, the planning spreadsheet, open in front of me.
Yeah.
And 32 meters
Yeah.
flying height with the AFX10 would give you just under 3 centimeter ground sampling distance. However, you would have these issues that I described in my presentation regarding the IMU alignment, but all of those aside and controlled in a way or another, it's just under 3 centimeters. Now, there is a further point here that I would like to bring forth, and that is sub-pixel detection. You might look at a certain GSD to detect the same size of objects, but one of the exciting things about hyperspectral imaging is that you can actually detect targets which are smaller than your GSD. And how this is done, especially if you have a spectrally monotonous background, like you could assume of water or sand, whatever. Asphalt, exactly. Then you are using NV tools to suppress the non-interesting spectral features away, and what you are left are major anomalies, even if those anomalies are very much smaller than the actual GSD. There is this old, often quoted example of some research entity doing airborne survey somewhere in California, and finds a very interesting organic spectra from what was a swimming pool in the backyard of some house. They went to see that, and they found a floating prawn on that pool.
Okay, cool.
So this is something that it's just one of the many ways you can use the hyperspectral imaging.
What are the most common indices used in geology work, anything associated to? So here I would say you need to Google, because there are a lot of indices related to different type of mineral, related to different type of vegetation as well. So I don't have a favorite link. I know that on Google you can find a lot of them. Actually, with our processing software inside, there is a possibility to have already like some preloaded indices like this. Yeah, I don't have a favorite web page, but I know that on Google you can find a lot of them. I am also very interested in the ability to identify invasive plant species. However, again, this is interesting because the plants show differently depending on their maturity and the seasons. Yes, and I would even say it depends if you're at the morning and the evening, because for example, I had like customer who are using like our camera for looking at NDVI for different places, for different plants, sorry. And then you could see that it was even changing, you know, morning, evening. So yes, here you need to basically make model that take into account all the variability you could have for your plant species. This is the same for every model. If you just give a spectrum for one plant species, but it doesn't encompass the full variability you could have, your model cannot be accurate. So you need to teach this is a young, more mature, or different type of growing stage for your plant.
So if I may add, Matt, Craig, the vegetation survey, this application that you are interested in, is totally doable with this technology. I can guarantee you that. But it's more work than doing a, let's say, geological surface modeling, because of the reason what Matt said. Plants are highly variable in their spectra. So the way these kind of surveys are typically done, you get a point spectrometer and you go in the field as close the same day as flying as you can. You create a spectral library of those species that you want to collect, let's say within a week and around the same time of the day that you expect to fly. And then you start getting good matches.
Can you explain how the data volume expands so much when not flying north, south, or east, west? So I think, Petri, you had a slide for that. So basically, NV, or the data format, makes a square window or rectangle window. So if you fly southwest, it fills, like with dark dot, or dark data sets, dark points. And here you need to have anyways the spectral data. They are 0, but you still need to have the spectral data. So that's why it's feeding actually like the data. What software do you suggest for post-processing the hyperspectral data? You or me, I can do. So with NV, basically you can open the data, the raw data. And then we have Calibration Pro, which is our software, but which needs to have NV as a root to convert the raw data into radiance and also to georeference them. But then if you want to convert the radiance data into reflectance data, you need to use another tool. In NV, you already have some feature. You have Flash, you have Quark, which stands for quick atmospheric correction, but you can use also ATCore, which is one solution. And I remember, Petri, you mentioned another one which is really dedicated for drone, which is actually better, taking into account the lower altitude, of the
DrawCore. It's from the same company as the ATCore.
Yes. Thank you. Yes, this question next. How many prediction of macro or micronutrient, I think, of soil by AFX to prediction of soil macro and microelement in sieved and ground soil using laboratory image? I have to read it again. Unless, Petri, you want to dive already in it, but to read it is again.
Well, I'm if I understand this question correctly, is basically he might be asking how many end members can you draw from soil samples?
That's what I would understand as well.
It's basically endless. It just depends on the quality of your collection data as well as your processing. It's easily hundreds. It depends on how many bands and how good SNR. There is no number to give you, but it's in direct relation to the quality of your data, raw data, and the quality of your processing, and above all, your analysis.
Is there a FODIS to convert image signal to reflectance? No. So I see Petri is looking at me and I look at him. So no, yeah. We had it in the past. We had a FODIS in the past, but we don't do it anymore because it's eating actually some of the pixel, which is like covering a field of view and not even at the middle. So it means that you have a field of view which is not centered at the middle anymore. And Petri, you mentioned actually that's the issue when you have a FODIS. You measure what is the incoming light from the sun at the level of the flying platform, but not at the ground level, which is something which is really crucial as well. And you mentioned as well, because I have to say we had the question this morning, you mentioned as well that the orientation of the FODIS antenna might not be the most appropriate depending on the direction of the sun.
Especially because the field of view of the sensor might be limited. And above all, because it's mounted on the aircraft, which is never completely level, you are turning, you are, depending on your fuel status, you have nose higher or lower. All this is changing your result. Well, what if you have a cloud above you? The shadow is thrown past your target right below you, but the FODIS is measuring the illumination from the cloud. So it's completely wrong. The list of challenges is endless. And if you're looking into the literature, scientific literature about the downwelling irradiance collection in the airborne environment, it's very long. It's been tried since 1948, and it hasn't stuck because of all of these complications. In this realm, as we are talking about UAV collection, my recommendation is to get a separate handheld downwelling irradiance sensor. They exist, and be there when you collect the irradiance at your target. Obviously, it doesn't cover everything if you have a very large area. So this is mainly for, let's say, a smallish research type applications, but that's the best we can offer.
So next question is, could you please provide information about the price of this technology? Yes, we can, but not here, because there are some competition ears all around. So I'm happy that we have competitors looking at us, but please, for price information, send us an email, info@spekim.com, and then we will come back to you to give you a pricing idea. Could you please suggest software to post-process hyperspectral data? So we already mentioned, for instance, NV. That's one. For hyperspectral imaging in general, there are more software available. There is ours inside. The data can also be opened easily into MATLAB or Python. Those are the different possibilities as well. So those are the one coming to my mind available. Yes, okay, that was a question. Do you have any feedback from Gremsy gimbals users?
Yes, they work great. They are totally usable.
Thank you.
Actually, it is a Gremsy that I had in my presentation earlier on in the slide.
Does the sensor have an incoming solar light sensor? So no, that was the same question as the 40s, basically. Can we phenotype farms in order to classify plant health, ripeness, and water level? Yes, that's a typical application for precision farming. So here, yes, AFX10 would be the perfect tool for that. Could you please provide information about the price? Sorry, that was the same question. Yes. Could you explain more about how to select suitable spectra and spatial binning? That's a good question. That because it will go after to the SNR. So, but first, let's start about like select the best spectral and spatial binning. I will start with the spectral binning. So you need to consider what you want to sort from each other. Does your application require to have a high spectral resolution, for example, 5 nanometers, or your application is sufficient with a spectral resolution, for example, of 10 or even 20 nanometers? This is the first thing you have to think about. Do you want to separate plants from each other, or do you want to see traits? So, for example, water. So this is the first question you have to think. If you don't need to have a high spectral resolution, then I really encourage you to use this spectral binning. Then you could think the same way with a spatial approach. Do you need to have a high spatial resolution with depend on your flight or your flight height, of course, but with only, for example, with FX10, 1024 spatial pixels, only 512. If you don't need to have a high spatial resolution, then I encourage you to actually use spatial binning. And here, Petri, actually in your presentation, you were mentioning, and please, I'll let you go ahead, it has an impact on the SNR as well.
Yes, indeed. So the more you bin, in effect, the larger the single pixel, because when you bin, you are kind of putting the FPA, the detector pixels, into the same bin. That's where the binning name comes from. You essentially increase the surface area of your single pixel, so you catch more photons. But at the same time, you have less resolution, and you can choose if you have a less resolution in spatial or the spectral dimension. But when you increase your pixel area, you can go faster, you can collect better SNR. So this is one of the definite strengths on the SPECIM's sensor. They've always been, apart from being designed as a scientific measurement instruments, which are characterized / calibrated, they are also configurable to serve all these different applications, also regarding the SNR in different conditions, speed and resolutions you're getting in both spatial and spectral dimension.
And there is even a metric. So for example, like the SNR is in proportion of the square root of the binning factor. So if you bin by 2 in one direction, You multiply your SNR by the square root of 2, which means 1.4. So you increase already by 40% your SNR just by doing the binning. So that's really crucial.
You are better in math than me, Math. So thank you for this.
That's my name.
Exactly.
So,
there's the pun.
Do you provide sample data? We can provide sample data. So that's not a problem. I'm sure that Petri has wonderful sample data. We have as well. So we can provide this kind of things.
Certainly.
We have a Kestrel 10 camera. Thank you. Could we collect the data continuously like a carpet and then select start and end frame in CaliGeo? Or should each data line be acquired by start and stopping the light recording while in flight? This is
I think I understand what the Michal is asking. I think this is what I've been doing before, putting the sensor. In my case, it was also Kestrel in the back. Before this AFX automation was created, we put Kestrels in UAVs and we put them flying the autopilot flight, and we started it before takeoff and we stopped it after landing, and it was collecting throughout the whole flight, across all the turns, and whatever maneuvers it was doing, the Kestrel was collecting. And the answer to Michal is yes, you can. The difficulty there is to really decide or work out which line number is the beginning and end of each line that you are interested in. You can iterate it. You can just test it. You can choose from this number to that number. You can do that in CaliGeo Pro, but it takes a bit more work to work out which line numbers you really want. But it is possible. So the short answer to the question is yes, you can.
I'm going to write the project for rural people for agricultural production, soil, plant, water, quality health. Sorry, it has moved. Soil, plant, water, quality, health, stress detection. Could I use in the meantime the AFX-17 to detect breast cancer for rural women in Turkey? Oh, well, the AFX-17, the thing is that if you want to use it, for instance, like outdoor and in the lab, I will not use that, because the thing is, like, when you use it in the UAV, you have what we call the geometric calibration. So that means that you focus the lens basically to the infinity. So if you start to use the camera as well in a lab, you will have to refocus the camera, and then you will lose, the geometric calibration. So I will not do that. For your application for breast cancer, yes, I have seen this application actually with an FX10 or with an FX17, like for tumor removal. So you imagine you had like, you're in the surgery block, and then the person is open basically. And by looking with a hyperspectral camera, it's possible to detect basically if you have removed all the tumor or not. So I have seen this application, but I will not use the AFX17 for that.
Matthew, you being professional, do you ever stop thinking how crazy amount of applications you can use this technology for? I mean, from agriculture to forestry to medical applications. It's absolutely awesome. This is why I love this technology.
Currently, we are using FX10 in order to collect data on specific plant. We have created DNNS, so deep neural network, in order to precisely classify plant states. Can we use related model in order to use in bigger farm by taking into account reinforcement learning with UAV data? Well, here you have to be careful, because when it depends how you acquired your data. Because first of all, if you acquired your data in a lab, I assume you were using artificial light, maybe not. If you were using artificial illumination, the atmospheric absorption bands are not taken into account anymore in your DNN, the one you have from your lab experience. When you fly with your UAV, the incoming light is not the same, and then you may have bands which were important for your first lab applications that you will not find anymore in your airborne acquired data. So here you can have the atmospheric absorption, which is going to disturb basically your model. So here, I would say you make great research, it gives some good idea, but the transposition directly like this might be a little bit tricky.
The answer is do all of this from the UAV data.
Yes, that will be the best. Maybe I missed, do you sell UAV, sensor, and software needed as package? Pekim, we sell the camera, we sell our software, we can recommend some UAVs, we can recommend as well some processing software, but we do not sell them. That was the last question, and I have to say we got a lot of them. Thanks a lot. Thanks a lot to everyone. And again, Petri, thanks for your expertise. Thanks for being here. Thanks for making this nice presentation and explain all our audience how to acquire nicely the data. I see we have a last question, and that's the last one we're going to answer because it's already quite a long webinar for now. So we reread it, and after this one, I will close. We have collect data both from lab and field data and train model today. That was basically the same kind of related to the previous one. Okay. So yes, again, Petri, thank you everyone as well for this webinar, for the attendees. And so if you have any question, please do not hesitate to contact us, info@pekim.com or Petri from Actualis Maps. And I think maybe Harry, you can put the email address. It's already there in the chat for Petri. Thanks a lot, and have a nice morning, evening, day, wherever you are located.
Thank you for having me.
Thank you.